Alright, so if we have a phase shift, then how is that going to affect our graph? Well, that means we're going to start at a different place. The general formulas for the main two graphs that we're going to look at with phase shift are y equals a sine of omega x minus phi, and y equals a cosine of omega x minus phi. Alright, so same basic or general formula. So what's different here that we haven't been having is that minus phi inside of the parentheses here by our omega. And the first thing that we have to do whenever we have an equation that we want to graph is we have to factor the omega out. Okay, we've practiced that a little bit, but I'm gonna throw another problem up here so that we can practice at least one more time. So I'm just gonna make one up for us. So let's say that we had y equals 2 cosine of 2/5 x minus pi. Alright, so the first thing that we want to do is factor the omega out. Alright, the omega is whatever is in front of the x. So it's going to be 2 cosine of 2/5 times, and now that's going to be x minus, and what do we have to do to factor 2/5 out of pi? You have to divide it, right, by 2/5. So if you need to do that over to the side, that's okay. Pi divided by 2/5, you would flip and multiply, right? So you would have 5 halves pi, or 5 pi over 2. So whatever you have in front of the x, you want to factor out. Alright, whatever it is. Doesn't matter if it's a pi, if it's a fraction, if it's a whole number, you want to factor that out, and then you want to make sure and divide this last term here, your phi, you want to divide that by whatever you factored out. So that's going to change that, and that's a big deal. Alright, why is that such a big deal, you may be asking? Well, the phase shift, or our new starting point for our graph, is going to be whatever we have right here. So let me do another one, maybe one with that will be a little more typical as to what we were doing. So let's say I have y equals 4 sine of 2x plus pi over 3. Now the first thing that we need to do is factor out the omega. So we rewrite the equation. That's 4 times the sine of 2 times what? X plus, now we have to say pi over 3 divided by 2. Remember, dividing by 2 and multiplying by 1/2 is the same thing. So that's going to be plus pi over 6. Okay. Now, how is this equation different from the one that we just worked out? Other than in having more fractions up here, what do we notice that was here that's not here? A minus sign, right? And that's going to make a difference. Look at my formulas here. What do my formulas have in them? They both have minus signs. So that must make some type of difference, and it does, and I'll tell you about that in just a second. But we do need to keep in mind, like I just said, a plus or a minus makes a difference. So what difference does it make? All right, the phase shift, or your new starting point, that's really what the phase shift is. So if you ever say phase shift equals, really what we're saying in layman's terms, or in regular old words, we're saying that that's going to be our new starting point of our graph. And that starting point is a position or a place on the x-axis. Okay? So in our equation, the starting point is going to be your phi divided by omega. All right. Now, from our general formula up here, some of you may have written it down. If I factor the omega out to rewrite the general formula, you know, we did it with some real numbers, but if I do that in my general formula, that would give me x minus phi divided by omega, right? I'm going to do that for both of these general formulas. So if I factor out an omega, that's going to leave me with x minus phi divided by omega. All right, so in my formula, I have a minus right here. So when you have a minus right here, your phase shift is simply omega over phi divided by omega. So if it's negative here, your phase shift is going to be positive. If it's positive, if there's a plus sign in front of it, your phase shift is going to be negative. All right, so that's the difference in the plus sign and the minus sign. If you have a minus in front, you have a positive phase shift because of the formula. If you have a plus in front of the phi over omega, like this problem right here that we just worked out, the phase shift, or the new starting point, is equal to negative pi over 6. So that's where we would start one complete period on the x-axis at negative pi over 6. Now we're not going to do one like that to start with because it is a little more complicated if you start on the left side of 0 than if you start on the right side of 0. Not much different. It's the same concept, but I would rather do one where we start with positive values. All right, so let me come up with one more. Somehow, some way, let me figure out one more. All right. Let's say that we had I know you're waiting patiently. Let's say that we had y equals 2 sine of 3x minus pi over 2. All right. The first thing that we need to do to graph that equation is we need to rewrite the equation by factoring out the omega. So if I factor out a 3, that's going to give me x minus, what do I get whenever I divide pi over 2 by 3?
Pi over 6.
Pi over 6, right? If that confuses you, remember, dividing by 3 is the same as multiplying by 1/3. So that's why we get a pi over 6. Okay. After you rewrite the equation, the next step is to write down some of those same things that we did before when we were graphing. We need to write down the amplitude We need to write down the period. We need to write down the phase shift. And remember what the phase shift actually is. That's our new starting point. On this one it will be, yes. It will be positive on this problem. And then we're going to come up with our ending point, meaning where does one complete period end? All right. So the amplitude here is the absolute value of 2, which is 2. How do I figure out the period? It's 2 pi divided by omega. So what's our omega here? 3. So one complete period will have a length of 2 pi over 3, or 2/3 pi. Now, our starting point for our graph is going to be at a positive pi over 6 because there's a minus in front. Now remember, this the period, that's a length on the x-axis. The phase shift, pi over 6, that's a starting point on the x-axis. Now what about the ending point? How could I figure out where my graph is going to end if I know my starting point and I know how long, or I know the period of my graph? That's right. You take your starting point or your phase shift and add your period to that. So the ending point, and this is on the x-axis, the ending point is going to be the period plus the phase shift. You can write it either, you can say 2/3 pi plus pi over 6 or pi over 6 plus 2/3 pi. So period plus starting point or starting point plus period. And what do you get? I need to get a common denominator, right? So that's going to be 2 pi over 3. Is that right? Can I put the 2 pi up here? No, I can't because they don't have the same denominator. So I have to say 6 divided by 3 is 2. 2 times 2 pi is 4 pi. Plus, now what do I do for this term? Yeah, just bring the pi down. So what's the ending point going to be? 5 pi over 6. Alright, so what we have done is we have figured out where we're going to start our graph and where we're going to end our graph. So that means one complete period for this graph is going to be between where and where? Pi over 6 and 5 pi over 6. Our starting point and our ending point. Now the distance between the starting point and the ending point is the period. Now from this, since I know the starting point and the ending point, I can make 4 subintervals. Remember, those subintervals are evenly spaced apart. I know that I'm going to start at pi over 6, and I know that I'm going to end at 5 pi over 6. Now think back, how do you get that change in x, or that increment, or whatever you want to call it, that space? How do you get that value that you want to add to a significant point to get the next significant point? We did that before. You take the period and you do what? Divide by 4. That's right. Take the period and divide by 4. We're taking the length of the graph and we're dividing it by 4. Because remember, there are 4 even subintervals. So they will each have a width of whatever number we come up with. And that number is always the period divided by 4. Whether you're doing a phase shift or you're not, each increment or each width of each subinterval is the period divided by 4. So if I take the period and I divide by 4, that's like multiplying by 1/4. Alright, I get 2 pi over 12, which is pi over 6. Alright, so for this graph, each one of my subintervals is going to be how wide? Pi over 6 units wide. Alright, so how do I get this next number right here? I say the previous, which before was just 0 when we were doing this, but it's not 0 anymore. I say the previous point, pi over 6, plus this magical value that we came up with, the width, which is pi over 6. So that's 2 pi over 6, or pi over 3. So that's what I start my next subinterval with, pi over 3. Oop. And so now this next point is going to be pi over 3 plus that same width, pi over 6. So that's going to be 2 pi over 6 plus 1 pi over 6 is 3 pi over 6, or pi over 2. And then this value here is going to be 3 pi over 6, or pi over 2, plus pi over 6, that same width. That's 4 pi over 6, or 2 pi over 3. And now here's the self-check. Here's the built-in, am I doing this problem right part. And sometimes students take this for granted and don't check this, and then they did it all wrong. So here at the end, since we know we're supposed to end here at this x point, this x value here, take the previous 2 pi over 3 and add pi over 6 to that. Alright, so that's 4 pi over 6 plus 1 pi over 6, or 5 pi over 6. So it checks out. So we did the math right according to how we set this problem up. Alright, so now I can sketch this graph. Alright, so this is y equals 2. I'll just write it to the side. Y equals 2 sine of 3 times x minus pi over 6. Alright, so we're going to start at pi over 6. That's our first significant point. Now, pi over 6 is an actual number that you can figure out, right? If you want to, you can type in your calculator pi divided by 6, and you'll get something a little bit more than 0.5, I think, something like that. So you know that's a positive x value, so I'm going to put like pi over 6 right here on the right side of 0. I don't want to put it way far away from 0. I want to keep my scale kind of consistent whenever I write my first point. Now, I may not know these other points, which I do because I have them written down, but I do know that from this place here where I start, the rest of my points have to be evenly spaced out. Okay? So try to make them as evenly spaced out as possible. If you're using graphing paper, of course, you can space them out pretty evenly. So this first place is pi over 6. The next significant point is pi over 3. The next significant point is pi over 2. The next significant point is 2 pi over 3. And the last significant point is 5 pi over 6. Okay? Now we have to remember the pattern for sine. Also need the high point and the low point. What was it? What was the amplitude? 2. So my high point's going to be 2. My low point's going to be -2. Those are on the y-axis. Now remember the pattern for sine. Sine starts at y equals 0. Right? Well, it starts at x equals 0 and y equals 0. But we're starting at pi over 6 because there's a phase shift. That's our starting x point. But we usually start at y equals 0 right here. And then at the next significant point, we have a high point. At the next significant point, we cross. At the next significant point, we have a low point. And at the last significant point, we cross. And we know that it has a shape similar to that. Hills and valleys. All right. If I was able to reproduce this graph to the left and to the right forever, then that would be the entire graph. I mean, this thing does repeat. Right, it's gonna go down, then it's gonna come back up, and then it's gonna go back down, and it's gonna do that in both directions forever. But by us drawing one complete period like this, starting our graph where we're supposed to start it, and ending our graph where we're supposed to end it, we have that basic shape of the sine curve. Now, if you do this in a calculator, it's not just going to graph that little piece. It's going to graph, whatever it would normally graph over and over and over. Let me show you what I'm talking about. So I'm going to type in the graph without factoring out the omega and show you that it is the same thing. All right, so just 1 second. So I'm going to type it in again when it's not in the factored form, just to show you that we're going to get the same thing. So it's 2 sine of 3x minus pi over 2. All right. It's not letting me, there it went. Okay. So how can we know that this graph is the same as what we have? Well, we're going to have to think about what our graph is with decimal approximations. Like, we don't have pi over 6 on our x-axis. So we only have whole numbers. So we need to use a calculator of some type. All right, and so pi divided by 6, I told you earlier, is It's a little bit more than 0.5, a little bit more than 1/2. So that's our starting point. Let's see what our ending point's supposed to be. 5 pi divided by 6. So 5 times pi divided by 6. So we should end at a little bit more than 2.5. So let's look at our graph in the graphing utility. So 0.5 would be between 1 and 0 right here. So that's where we start. And then 2.5 is 1, 2. There's 2.5 right here. So you can see up, down, up, and we end just a little bit more than halfway between 2 and 3. Okay, and that's one complete period. But if we could continue that in both directions, this is what our graph would look like. All right, so we may want to use your calculators to help you approximate your x values so that you can compare your graph maybe to graphs that are on the homework or on the test or whatever. But if you were doing this for me on the test, what I would expect from you would be, I'd expect you to first rewrite the equation correctly and then list the amplitude, the period, the phase shift, and the ending point. List the entire interval for one complete period. List the 4 subintervals. And then, of course, after that, we graph. And we can use our scales that we want to use. We don't have to use the ones that are provided. We can just, even if there is one provided, if you don't like them, just change the values on there. Okay? So as long as you write down those significant points and you follow the pattern of the graph the way it's supposed to be followed, you'll have a good representation of the graph. All right, let's do another one. That was so much fun. I want to do another. Let's do a cosine graph. So let's say that I wanted to graph y equals 3 cosine of 2x plus pi. All right, so the first thing that we would want to do is factor the omega out.
Is the whole negative and positive still apply on cosine?
The negative or positive in the equation is going to matter here. All right, so rewrite the equation by factoring the omega out. So it's going to be 2 times. Sometimes students forget and they just leave this last thing the same number, and that won't work. All right, you have to divide this last number by whatever you factor out. So that's going to be plus pi over 2. All right, so the amplitude is going to be equal to the absolute value of 3, which is 3. The period is going to equal to 2 pi divided by what? 2. So the period's going to be pi. The phase shift or starting point is going to be equal to a negative pi over 2. And that's because there's a plus right here. Remember, that's an x value. So our x, on our x-axis, we're going to start at negative pi over 2. And then the ending point for one complete period, or the end point for one complete period, is going to be the phase shift plus the period, or period plus the phase shift. So negative pi over 2 plus pi. The phase shift plus the period. Yeah, right. pi is, if you get a common denominator, is 2 pi over 2. So 2 pi over 2 and negative 1 pi over 2 is just going to be a positive pi over 2. So you got to get a common denominator and put those together. Just put the number parts together, the 1 and the negative 1/2, and then throw a pi in there. Everybody likes to throw pies, right? Alright, so that means that the interval for one complete period is going to be from negative pi over 2 to positive pi over 2. And from that, we're going to form 4 subintervals. And one thing we know for sure is we're going to start at negative pi over 2, and we're going to end at pi over 2. Now, how do we get the value that we add each time?
You take
The period and divide by 4. That's right. Because it's a width. It's the width of each subinterval. So you say the period dividing by 4 and multiplying by 1/4 are the same thing. So that is how much we're going to add each time. We're going to add pi over 4 to the first significant point to get the next significant point. So here, that's going to be negative pi over 4, negative pi over 2 plus pi over 4. So what's that going to give me? All right, what is negative pi over 2? That's negative 2 pi over 4. So negative 2 pi over 4 plus 1 pi over 4 is be negative 1 pi over 4. Negatives and positives. Alright, we're going to start at negative pi over 4. Then how are we going to get this one here? You're going to say negative pi over 4 plus pi over 4.
0.
That's 0. So start here at 0. I know I don't have to write this down, but just to stay consistent, since so many of you are taking good notes, I'll write it down. 0 plus pi over 4 is? Yay! We got that one right. Now here's where we can check and make sure, I'm just picking. Here's where we can check and make sure that we've been doing stuff right. So right here, you take the previous number, pi over 4, and you add that same number that we've been adding every time, that width, pi over 4. Well, that's 2 pi over 4 or pi over 2. So we know that we added all of our fractions correctly, all of our radians. Alright, now, are there any questions up to that point? If there are, you can text me, since I see you're using your phone so good. Right? Just kidding. We don't use cell phones in class, we know that. Alright. One day I'm going to be broke down on the side of the road, you're going to pass me, and I'm going to be like, man, I wish I wouldn't have been so mean to you in class. You would have stopped and helped me. Anyway. Remember, these are all x values, okay? That's a big deal. Because if you look at our key points, 2 of those are negative, right? So that means that 2 of our values are going to have to be on the left side of the y-axis. Over here on the left side of the y-axis, or on the negative x-axis. If we don't put 2 points over there, then we're not going to be able to draw this correctly. Luckily, that next point is 0, so we'll be able to space it out evenly. What's hard is if that next point isn't 0. If it's like somewhere over here, then you have to be able to spatially, recognize that and make sure that in between each significant point, we keep that same width. All right, so let me do this in another color. So that is 2 times x plus pi over 2. I want to write it down one more time. It's 3 cosine x pi over All right. So two of those values were negative, this one and this one. So that means that when we start our first point right here, everything else that we draw needs to have the same width. So, because we have 4 subintervals. So we have this one that's negative pi over 2, this one that's negative pi over 4, this one here is 0, this one here is what? Pi over 4, and this one here is pi over 2. Alright, and the amplitude is 3. So I'm gonna go up 3 tick marks like that. You can adjust your y-axis ever how you see fit. Alright, so we have to remember the pattern for cosine. Remember, cosine's not the same as sine. Cosine starts at a high point. So where we're going to start our graph up here at a high point. Then at the next significant point for cosine, we cross. At the next significant point, we have a low point. At the next significant point, we cross. And at the last significant point, we have a high point. And we don't just draw a V. Remember, these are hills and valleys. So it looks something like that. So that's one complete period. Keep in mind that that will continue that same pattern to the right of our endpoint and to the left of our starting point forever. Now these values that we were using were kind of small. If you think about it, pi divided by 2, you know, if you want to know what that is, you could come to your calculator and say pi divided by 2. 1.57. So if we were looking at values in the calculator, what would that mean? That means right here, that would be negative 1.57-ish. And that would be positive 1.57-ish. So our window on the x-axis on the graphing calculator is usually like negative 10 to 10 or something like that. So what that means is if we were looking at that graph, there would be a lot of these periods that's going to be shown. So let me put that in the calculator and show you what I'm talking about. All right. So here's what I have in the graphing calculator. Remember, I said our starting point was around negative 1.57-ish. So that would be in between negative 1 and negative 2. About right there, that's where we start. And then we cross at negative pi over 4. So that's going to be less than 1. It's going to be about 0.7 something. And then this is kind of a, I guess, it's not the most important point, but here at 0, we know we're supposed to have a low point because of the pattern. High point, cross, low point. So that one's really easy to tell. And then we cross again at positive pi over 4. That's about 1. It's about 0.7 something or 0.8 something. It's right around there. And then you end one complete period at positive 1.5. And positive 1.57-ish is between 1 and 2. So it's about right there. So that's what we've drawn, just between there and there. And then if you continued that to the right, to the left forever, you'd have your graph. Now there are some things you need to keep in mind that can change this just a little bit, like what happens if there's a negative in front? Well, that's just going to make the pattern that we use flip. Instead of starting at a high point, we would start at a low point. So you have to keep that in mind when you're graphing these. Watch, if I put a negative in front, you know, I'm not going to have high point cross low point cross high point. I'm going to have low point cross high point cross low point. So watch this. It's just going to flip over. So we have to start at a low point, then you cross at the same places. It's just all the high points and low points are switched. Okay? So remember that about sine and cosine. That's very important. Let's do another one that is a little different from those two. Let's say that we had y equals 4 sine of pi x minus 2. This one is actually kind of tough, because what is our omega? Pi. So when we rewrite this, this is 4 times the sine of pi, and then factor it out. You have x minus 2 over pi. So we are going to have to use our calculator on this one, unless you can do lots of division with decimals in your head, which I don't suggest doing. You're going to want to use a calculator to help you on this one for sure. Not a graphing calculator, just a calculator to get those x values to make sure that we put them in the right place. Now let's follow all the same steps though. Every step's going to be the same. Let's write the amplitude. It's going to be 4. Let's write the period. It's going to be 2 pi divided by pi. So it's going to be 2. So 2 units. Let's write the starting point. Sometimes I write the word starting point. Sometimes I write the word phase shift. It means the same thing for us. So it's going to be positive, because there's a minus in front, positive 2 over pi. And now the ending point that's going to look kind of strange. But that's okay. So it's the starting point plus the period. So 2 over pi plus 2. Alright, even though it's going to look strange, we're going to do everything the same way. So that means that my interval is going to be from 2 over pi to 2 over pi plus 2. So I am going to need to work these out to see what they are decimal wise to help me out when I graph. But when we write it down, we want to write it down like this. And then just write the decimal approximation maybe underneath it or beside it. So this is going to be 2 divided by pi. You know, as long as you do 2 or 3 decimal places, you'll be good to go. So I'm just going to round everything to 2 decimal places just because we're estimating anyway. So that's going to be 0.64. So this number right here is about 0.64. And so what would that make this number right here about? 2.64. Good. Alright, so we just need to know where those are so that we can put them on the x-axis correctly. Okay. Am I ready to graph? No, that's right. I don't have the subintervals. So I'm going to space these out a little more because they are going to be like, the numbers aren't going to be bigger. Writing the numbers is going to be bigger, I guess I should say. I'm going to do the same stuff. What do I need to add to the first point to get the next point? Well, let's write down the first and last point first. Do the same thing. So I'm going to take the period and divide by 4. What's 2 divided by 4? 0.5 or 1/2, right? So I want to add 1/2 to this to get the next significant point. So that's going to be 2 over pi plus 1/2. And we can get a decimal approximation for that by just adding 0.5 to this, right? What was that?
1.14.
Would that be 1.14? Alright, then my next point, I'll start here. Next interval, I'll start here at this point. And then add 1/2 again. 2 over pi plus 1. So this one right here is about 1.64. Okay, and then I start out with 2 over pi plus 1, add 1/2 to that again, 2 over pi plus 3/2. 1 plus 1/2 is 3/2, right? So what's that going to about be? 2.14. And then just to make sure that I've been adding things correctly, if I add 1/2 to this one here, 3/2 plus 1/2 is 2. So I ended where I was supposed to. And I've already written down the decimal approximation for it. Remember, it was about 2.64. Alright. So now we have all of our significant points that we need. We have everything that we would ever need to give me a rough sketch of this graph. Now, wherever you start the graph, remember you want to space out all the other points evenly. So I'm starting the graph at 2 over pi, or about 0.64. So as long as it's kind of close to 0, not too far away, that's fine. So right there, that's going to be 2 over pi, or about 0.64. The rest of the points that I write down on the x-axis, I just want to space them out evenly. So there, 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 and there. So approximately. We're not exact here. Alright, so this x value right here is 2 over pi plus 1/2. This one is 2 over pi plus 1. This one is 2 over pi plus 3/2. And this last one here would be 2 over pi plus 2. Alright, let's see what my 4 sine pi. X minus 2 over pi. Even though it's really strange to have all of these weird looking numbers down here, I can still figure out those decimals. Just remember, they're just regular old x values with a decimal. Now we follow the patterns that we should. We have a high point and a low point. We have a high point of 4 and a low point of -4. And what's the pattern for sine? We start on the x-axis. At the next significant point, we have a high point. At the next significant point, we cross. At the next significant point, we have a low point. And at the last significant point, we cross. As long as everything is labeled correctly, that's all that really matters. And we follow the right pattern. Now, is it going to look like that if I plug it into the calculator and graph it? Probably not exactly. But we've been kind of approximating the decimals anyway. So you could do the same thing. You just approximate the decimals. You know, look at your decimal approximations and see if it's crossing in the places that it should.